Welcome you all, my dear students. We'll start our classes. Later. 1 minute. I am audible, right? Naveen? Okay. Now, from today we are starting soil mechanics. We are starting soil mechanics. This is a syllabus given by SSC JE. The syllabus includes soil mechanics means only geotechnical 1. Okay, this is GT1 or basic geotechnical engineering course what you have studied in UG, that will be covered here. But little bit from GT2 also it is there from GT2. Now here origin of soil, phase diagram, definition, White's ratio, porosity, degree of saturation, water content, specific gravity, and soil grain, specific grade of soil grains, unit weight, density index, relation between the different parameters. This is one day. This much we are covering today. And the next day from grain size distribution till plasticity chart. This is the second day. And this is the permeability from here till consolidation. Till here, this is the third day. And from consolidation it starts, settlement also included. Then it will be a fourth day. Then shear strength of the soil, direct shear, triaxial, soil compaction also includes in that. That will be your next day. In the last day we will be covering earth pressure and other parameters. Okay, this is how we are covering, and today we will cover these all topics till here. Okay, now okay, origin of soil and soil formation. Okay, before that we will just understand what is a soil, and after that what is a geotechnical engineering, and what are the branches of geotechnical engineering, and lightly we will go through why it is required and all. Okay, see here, geo means earth. You already know that this is a geo means earth. We have a earth like this, and inside we have a core, and after that we have a mantle. This is called as a mantle, and this one is crest. This one is a crest, and the entire this sphere is called as a earth. Right? This is the earth. Now, this earth, if you want to study entire the things, that is a core, mantle, and crest. If you want to study everything about earth, then that is called as a geology. Geology. Okay. And if you want to study the earth crust, whatever that is there, that is present on the earth crust, and that you will call it as a soil or rock. That if you want to study, that will come under geotechnical engineering. Here, the word geo is there, that indicates you are studying earth, and here a technical word is there. Technical means you are studying the technical point of view. Technical point of view because you want to build a building on that one, or you want to apply some force, pressure, stress, and you want to study the behavior of the soil. Therefore, we are calling it as a geotechnical engineering. This geotechnical engineering we will divide into two parts. The first one is the soil mechanics. First one is the soil mechanics, and the second one is the foundation engineering. Next one is the foundation engineering. Correct? Huh? Okay. You should know the meaning of mechanics first. The meaning of mechanics. The meaning of mechanics is apply some, stimulate something, stimulate and study the response of that one. Study the response of that one. Stimulate means you apply some force, apply moment, apply stress, apply torque. Okay, whatever you want to apply, just apply this one. This is called as stimulating the body. Body, which body you are studying? It might be a solids, it might be a liquid, it might be a fluid, it might be a air, it might be soil also. Now you are applying the force to these materials or any one of these materials, then you are studying the response. What response? Expansion, contraction, expansion, contraction, bent, that is your slope and deflection, or twist, or collapse. Okay, these are the responses of those materials. Now, interestingly, if you are studying this stimulates, and you are studying the response on solid, then that is called as the solid mechanics. That is solid mechanics. Then if you are studying these all forces applied on a liquid or a fluid, then that is called as a fluid mechanics. That is fluid mechanics. Then you are applying these all forces and studying all these responses on soil, then that is called as soil mechanics. That's it. That is called as soil mechanics. Now what is soil mechanics? Soil mechanics means you are applying forces, moments, stress, torque, or shear, compression, whatever that forces you are applying on that soil, and you are studying its behavior. Its behavior, whether it will expand, whether it will contract, whether it will bend, slip, twist, collapse, what will happen to that soil, that you are studying. Therefore this is called as the soil mechanics. Understood? Here whenever you are applying these all forces, then you are considering some laws. It might be mechanics laws are there, like Hooke's law is there, that you are applying on the soil. Then fluid mechanics laws are there, some fluid, like Pascal's law is there, that you are going to apply. Then there are some laws in water flowing through porous media, like Darcy's law is there. Darcy's law is there, that you are going to apply. Like that, you are applying various mechanics laws to the soil, then you are studying the response of that soil, then that is called as a soil mechanics. Okay, that's why this is a soil mechanics. Then what is foundation engineering? Foundation engineering is application of soil mechanics. Then whatever you studied in soil mechanics, those things you are considering to the soil. Okay, and you are studying the application part, that if you build a building on a particular soil, then how that soil will behave. If you build a retaining wall, if you build a slope, if you build a dam, bridges, abutments, when you build all of them on the soil, then how exactly the soil will behave, that comes under foundation engineering. Before that you will study soil mechanics. Right? Diploma level, because this SSC is diploma level, therefore they are very interested in soil mechanics rather than foundation engineering. Foundation engineering is the application part, therefore VTU students will study this one as a geotechnical 2, GT2, they will study it. In GT1 whatever that is covered, that is your soil mechanics, and that is included for your SSC JE syllabus. Understood? Now soil mechanics, you got it. Then who that one coined this term soil mechanics? Is there any person? Soil mechanics, or whatever I explained till now, who explained that one first time? That is a Carl Terjigi. That is Carl Terjagi. Carl Terjagi, who is known as father of soil mechanics. Who is father of soil mechanics? You remember this one, father of soil mechanics. And this definition, whatever I told, is given by this Carl Warren Terge. That is a father of, he is a father of soil mechanics. Right? Now we will study origin of soil. How soil is origin, you know, how it is developed on the earth. As it is said that earth, the topmost layer of the earth is made up of what? It is called as a crust. It is called as a crust, and crust will be having lot of rock material, and it has a soil material. Then how this soil formed? We have one philosophy, that is weathering of rocks. Weathering of rocks means thousands or 2000 years or lakhs years before that, the rock was like this, and the topmost layer of the rock was started weathering. Weathering means just it is getting powdered. You know, this top layer of the soil getting powdered, and this powdered material is called as a soil. And this material may stay near to the rock, or this powdered material may transfer from one point to other point and may be deposited at some other point. Now, this powdered material is called as a soil. That is weathering of rock. Soil formation is by weathering of rock. Now this weathering of rock, this powder formation happened in a two different way depending on the climate conditions. The first condition is mechanical weathering or physical weathering. And the second condition it happened is, that is a chemical weathering. Chemical weathering means by using some chemical properties or chemicals, that is they are the main cause for this weathering. And physical weathering means physical activities are main cause for the weathering. Right? Now, if I list some of the physical activity that they are causing the mechanical weathering or physical weathering, they are like human action, human action, you know, or change in temperature, right? Or wind action, or flow of water, flow of water, or frosting and frosting and thawing, you know. Then root action. These are the physical events that occur on the surface of the rock, and the rock will start weathering. That is called as a physical weathering. First best example is human action. Human action, because nowadays we are just demolishing the rocks and making it as a powder, either it is a stone or aggregates. You know? When we do this process, then the powder form will be formed, that you can call it as a soil. Temperature change. Temperature change is when temperature increases, then the soil expands, and temperature decreases, rock expands and temperature decreases, rock contracts. This contraction and expansion process, between this contraction and expansion process, soil, rock will get powdered. Rock will get powdered. That powder formation is a soil formation. That's why change in temperature. Wind action, continuously wind blowing on a particular rock, okay, and it may erode some part of the soil, that is a wind action. And flow of water, when the water is flowing on the bed of a rock, then it will carry a small particles of the rock, that is disintegrating the rock, and that will form the soil. Frosting and thawing action, for example, this is a rock, frost action. Then water will store here. Then this water in ice, in cold winter season, it become ice. It become ice. When this water become ice, then it will expand. That ice will expand, therefore it will form some cracks in the rocks, therefore this rock will be disintegrated. Then root action, for example, if this is a rock with some cracks here, and inside some soil is there here. Let us consider some part of the soil is there, and here one small plant will grow. That plant will spread its roots inside, and those roots will disintegrate your rock, and the rock will be powdered. This is called as a root action, right? Like that we have many physical activities, those are causing the weathering of rock, right? Next, coming to the chemical weathering. Chemical weathering means there are some chemicals. It might be acid, or it might be base, or it might be solution, any form of the solution, or it might be any form of a reaction, you know, or it might be leaching. These all are causing the weathering of rocks. Then these are all called as a chemical weathering. Okay. Very interestingly, we have to remember that the soil formed because of physical weathering, usually they are granular soil. Granular soil means your and gravel, sand and gravel. Usually they are physically weathered soil. The chemical weathering soil, if the soil is weathered due to chemical, then the end product will be clay soil. Clays, sometimes it is a silt also. Clays and silts are coming out of the chemical decomposition or chemical weathering, and sands and gravels are coming out of the physical weathering or mechanical weathering. This is very important question. Many times it is asked. Okay, granular structure or fine structures. These are the main that you should know how they are originated. Right? By considering these all points, here it is explained that geological cycle of a soil formation. Initially, you will be having a rock, a hill made up of rock, and here erosion will takes place. Erosion, it might be a chemical weathering, it might be a mechanical weathering or chemical weathering. After that, there will be erosion of the soil. That erosion will transport from one point to other point. This transportation may be because of wind, or because of water, or because of human action. This soil will transfer and it will deposit on some area, and after that, after many years, that will again forms a rock. You can call this rock as a metamorphic or sedimentary rock. you know like that you will get again a rock, then again this rock will again start weathering, then this cycle will continue. That's why it is called as a geological cycle of soil formation. Means rock become soil, then soil become again rock, then again rock become soil. This is called as a geological cycle of soil formation. Understood? Now here you have to remember this. In this slide you have to remember very important points. The first point is mechanical weathering will leads granular structure, and chemical weathering will leads a clay type of structure. The first point. The second point from this diagram we have to remember is the soil when it forms, and few part of the soil will be stayed, that staying near to the parent rock. Let us consider this as a parent rock. This is called as a parent rock. And weathering of the rock happened, and that soil will deposit here itself. It will not move here and there. Just it is there here only. Then this type of soil it is called as a residual soil. This is a residual soil. If the soil is that weathering of the rock has happened and soil formation is also happened, but this soil is not staying near the parent rock, but it is moved from one place to another place, and it is deposited at some other place, then this is called as a transported soil. Transported soil. Okay, now it's very easy to remember what is the meaning of residual soil and transported soil. Right? Do you have any doubt in origin of soil? If you have, you can ask. 30 seconds will be given. Hope you don't have any doubts. We'll move ahead. Then I will show you the different names given to the soil based classification. These names are given based on the formation of soil. Classification is a different chapter that we will cover in the later, that tomorrow we will be covering the classification. Today, common names of the soil. This is a very important 1 mark question they may ask in the exam. As I told, the residual soil and the transported soil. The residual and transported soil are divided based on the parent rock, parent rock position. If the soil formation is happened and after that the soil is near to the residual, near to the parent rock, then that soil is called as a residual soil. And the soil is away from the parent rock, which is transported by any means, it might be wind, water, or human action, then that soil is called as a transported soil. Very easy to remember residual and transported soil. Okay. Next, this is an example of a residual soil, that is a saprolite. I think sometimes it is asked in some competitive exams. What is saprolite? No, saprolite is a one form of the mineral, and that is highly weathered rock or a soil material that retains its original structure but has undergone significant chemical or physical weathering. See here what happened, chemical or physical weathering has happened, but which is available near to the parent rock. You know that this slide will be shared later. You can read these points also. Next, laterite. This is a very common name. I think you have heard. This is a laterite. Usually, the red soil is considered called as a laterite, and this laterite is a residual soil. Very important. Laterite is a residual soil, and red soil is your laterite soil. Okay. This is through the weathering of the rock, rich in iron and aluminium. Very important. Rich in iron and aluminium, and this is used in construction of embankment or construction material in areas where suitable soil is limited. There you can use this one, bring that from somewhere and you can use this one. This explanation and availability you can read it later. Right? Then comes this slide is very important. You can see this one. The transported soil is listed here. Residual soil, we have a very limited residual soil, but transported soil we are just studying here. The transportation of the soil may be because of gravity, or it might be because of glacier, that is ice transportation, or the transportation may be because of water, transportation may be because of wind. You know, four type of transportation may happen. Gravity transportation is called as a colluvial deposit. Okay, na? Colluvial deposit, best example is a talus. Glacier deposit means transportation by ice. Then that is a glacier deposits, or the examples are Escarres, drumlins, glacial till. These are the examples of glacier deposits. Then the water transported soil. Water transported soil, we have two types of water, a fresh water transported and sea water transported. Fresh water transported, streams, hallagalu. Stream transported, they are called as alluvial soil. Example, shales and silts. These are examples of alluvial deposits. Lakes deposits, lakes keregalu. At the bottom of the lake, you will be having lacustrine deposit soils. Best example is clay, Warwood clay or marl or Warwood clay. Then sea deposit water is a marine deposit. That is marine means a sea marine deposits. Example is a marine clay or marl. Marl is here also and here also. Okay. Then wind transported soil, that is the aeolian deposits. Example is loess or sand dunes. Okay. This slide is very important. Here almost all terms are covered and they are all your transported soil. Okay. Go through once again. You can have a screenshot or otherwise later I will send the video also. That slide also. Right now, we can go one by one very fast. That is, you can see this one. This is your talus. Then go through this one. This is your ice deposit, and this one is stream deposit or stream transported. Then the next one is warwood clay, son papudi. You know, this you can remember it as a son papudi because it is alternate layers of clays and silts will be there. Alternate layers are there here. You know, this is your warwood clay, and you can go by marl. This is a clay. You can see this one. This is a marl, and we have sand dunes or loess. This is a sand dune or loess. Right? And some other names are there. Some other names like black cotton soil. Black cotton soil and boulder clay. Boulder clay means this part of the soil, whatever you are seeing here, that is called as a boulder clay. Very interesting thing about the boulder clay. Here also boulder clay is there. It look like a boulders. It look like a boulder, but if you wash that boulder with water, then it will lose its particles and it appears to be a clay. ಅದನ್ನ ನೀರ್ ಹಾಕಿ ತೊಳೆದಂಗಿಲೆ ಆ ಪಾರ್ಟಿಕಲ್ಸ್ ಎಲ್ಲ ಹೋಗಿ ಬಿಡ್ತದ. ಹೋಗಿ ಅದು ಕ್ಲೇ ಉಳ್ಕೊಂತದ. ಅಂದ್ರ ಅದು ಗಟ್ಟಿಯಾಗಿರ್ತಕ್ಕಂಥ ಬೌಲ್ಡರ್ ಅಲ್ಲ. ದೇರ್ ಫೋರ್ ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ as a boulder clay. ನೀರಲ್ಲಿ ನೆನೆ ಹಾಕಿ ಇಟ್ಬಿಟ್ರೆ ಅದು ಪುಡಿ ಪುಡಿ ಆಗಿಬಿಡ್ತದೆ. Next one is a calich ಅಂತ ಬರ್ತದ. Calich means cal is there. Cal means it is calcium you can call. Calcium means it is lime you can call. Then lime rich soil are considered as a calich. Okay. Then hard pan ಅಂತ ಬರ್ತದ. That hard pan, this soil will be appearing here. That is, this is one part of the soil and the other part of the soil. In between, that some clay type of soil will be sandwiched between the other two. Then that is called as a hard pan soil. Then we have a maroon. Maroon means that is a gravel parts also there and sand parts also there. Some clay parts also there. Therefore, this is a combination of all of them. That is your maroon. Right? This is all about origin of soil. If you have any doubts, you can ask. Do you have anything to ask in origin of soil? Okay. Then we'll go ahead. Okay, we'll go very slowly now because that is least important. Origin of soil, only 1 mark they will ask. That's why it was very fast. Now we will go by slow. Now, three-phase system of a soil. Three-phase system. Okay, three-phase system. Whenever you hold a soil in your hand, then there will be three phases in the soil. It may appear randomly like solid particles, and there might be water inside the soil, or there might be some air particles also. Okay, there might be air inside the soil. Then for study purpose, then I will divide this one into three different phases. This is your solids, this is your water, and this one is a air. Okay, now this is called as a three-phase system. Three-phase system. Okay, always remember solids are incompressible. Incompressible means this volume is there. No, this volume further you cannot compress. Solid means solid it is. No whites are there, no water, nothing. It is just a dry solids. Therefore, that is incompressible means you cannot further compress this volume. Then water is also incompressible. This you already know. Water is also incompressible. But water can be expelled. water can be expelled. Water can be expelled. Expulsion andre ಬೇರೆ, compression is different. This volume I can reduce. Look at here, very interesting. This volume I can reduce not by compressing the water, by expelling the water. ಅಂದ್ರೆ ಹೊರಗಡೆ ಚೆಲ್ಲೋದ್ರಿಂದ ಈ ವಾಲ್ಯೂಮ್ ಕಡಿಮೆ ಮಾಡಬಹುದು. ಓಕೆ, ಕಾಂಪ್ರೆಸ್ ಮಾಡೋದ್ರಿಂದ ಅಲ್ಲ. ಓಕೆ, then air is a compressible also. Air is compressible also, and expulsion is also possible. Expulsion is also possible. Andre this volume I can reduce or increase because air is compressible and expandable. And expulsion also andre ಹೊರಗಡೆನೂ ಹಾಕಬಹುದು ನೀವು. From this what we have understood is, we have understood is this volume never ever increase or decrease. This is always constant. This will never increase, never decrease. But this part of the volume may increase, may decrease depending on the condition. In rainy season, this entire volume may be filled by water. In dry summer season, this entire volume may be filled by air. That's why we can have two different state of soil. The first one is, this is a solid which will never change, and the entire top portion may be filled by water. Then this state is called as a saturated state. Saturated. Sometimes in summer season, this is a solid which will never change, and entire the top portion is filled by air particles. Then it is called as a dry state. Dry state means here we will be studying soil as a two phase. Soil as a two phase. Okay, now if I want to give some terms to these phases, then I can give the phases like this. Let us consider this is your three phase diagram, which is solids. This is a water. This one is a air. Okay, now this I will consider it as a volume of air. This one I will consider it as a volume of water. This one I will consider it as a volume of solids. You can make a note, volume of solids constant, right? Now that's why this is a fluctuating volume. No, this entire volume, this water volume and air volume is fluctuating. Therefore, that is called as a volume of voids. Volume of voids. Then the entire volume I can call it as a total volume. You just remember these words. V is the total volume, volume of air, volume of water, volume of solids, and volume of voids. Now I can write a equation, volume of water voids equal to VA plus VW. Correct? Then the total volume I can write it like VA plus VW plus Vs. Or you can write it like a VV plus Vs. This is your total volume. Right? Now I have a 5 different terms here that I will be studying. The first term is a voids ratio, and brother of voids ratio is a porosity. And another term I have degree of saturation. A brother of this one is a air content. Okay, and we have another term that is a percentage of air voids. This is a son of this porosity. Okay, now look at it. This is voids ratio. Voids ratio means how much voids are there. That is a ratio means what? You are comparing two objectives. The first one is volume of voids to the volume of solids. That is your VV by Vs. Okay, na? Top floor and bottom floor. The entire top floor, that is VV, and entire the bottom floor, that is VS. That is your top by bottom is a voids ratio. But porosity is top floor is compared to the entire building. Top floor is compared with the entire building. That is total volume. Understood? You remember like top floor by bottom floor, that is a voids ratio. Top floor by entire building is your bottom floor. This one porosity. This is called as a porosity. Okay, na? How many stores are there? How many stories are there here? Three-story building it is. This is just a three-story building. Correct? Now we have except ground floor, except this ground floor, we have a two first floor and second floor. No, those comparison will be here. That is a VA, sorry, VW divided by VV, and this is your VA divided by VV. See here, interestingly, this VA is compared with VV and VW is compared with VV. Means both are belongs to top floors, first floor and second floor, but both are compared there itself. Ground floor ಬರಂಗೇ ಇಲ್ಲ. That is your VW by VV and VA by VV. That is how much water is there in voids, how much air is there in voids. That's it. Then this is the sun because the topmost floor VA is compared with the whole building. See, this is also something similar to this one, but there is a little difference in that one. This is N porosity, VV compared with the building, and this is the VA compared with the building. That is your NA. This is percentage of air voids. Percentage of air voids. This is also called as percentage of voids. This is percentage of voids. This is percentage of air voids. Right? These five are very important. I will list it here. E equal to once again VV by VS, N equal to VV by V, then S equal to VW by VV, and AC equal to VA by VV, and NA equal to VA divided by V. Okay, na? Now there is a derivations between these all. Then we will be arriving some formulas. Those formulas are N equal to E divided by 1 plus E, or E equal to N divided by 1 minus N. Two formulas. Or S plus AC equal to 1 and N A equal to N into AC. Okay, these four formulas we can remember. These two formulas belongs to brothers, brothers. This is sisters. And these two formula belongs to sisters. One formula. This is a child, small child formula. Why I call like this? I will tell you here. We have E, N, AC, sorry, S, AC, and NA. NA, right? If you know E value, you can determine N value. Therefore, these two belongs to one circle. And if you know yes, and if you know yes, you can find AC. If you know AC, then you can find yes, because these two belongs to one circle. Then from here you get 1, and from here you get 1, so that you can define the third one. This is a derived one, derived from here and derived from here. Therefore, you will be having a NA. This is a child of these two circles. Understood? You remember all these 5 formulas. Now after that we have, again I will write a 3-phase diagram. This is your 3-phase diagram. Then this is your water. This is your air. Right now we studied about considering volumes, but now I will consider about masses. That this is a mass of air, mass of water, mass of solids. Mass of air is nothing but 0 compared to these two, therefore this is always 0. Then we have left with mass of water and mass of solids. Then what is the total mass? Total mass is mass of water plus mass of solids. Okay, na? Then here we have only two story, we have two story there. That's why you just compare the top one and bottom one. This top one and bottom one you just compare. That is your mw by ms is nothing but water content. This is your water content, right? Water content is mass of water by mass of solids. Okay, here only one term. In terms of mass we have only one term, and in terms of volume we have five terms, remember, right? Now coming to the other terms, they are called as the densities. Densities, again I will write a three phase diagram. Then this is a solid, water and air phase, and we have another phase where solids are there and entire water is there, and we have another phase that is solids are there and entire voids are filled by air, right? Then this phase is called as a bulk. Therefore the density obtained here is your bulk density gamma b. Gamma b is mass by volume, total mass by total volume. This is a total volume and this one is a total mass. Mass by volume is your bulk density. Then here also you will be having a total volume, and here you will be having mass of the soil, but it is saturated now, therefore I will call it as a saturated mass. Therefore gamma sat is nothing but mass of saturated divided by total volume. Then coming to here, this is the total volume present here, and this one is the mass of dry mass it is. Therefore gamma d is nothing but dry mass divided by total volume. Okay, now very interestingly, here I can say this mass of air is 0 means, and this one is mass of solids. Therefore I can write a mass of solids is nothing but dry mass. Remember this one, right? Dry mass and mass of solids both are same. Now we have three types of densities. Now we have another one, another density. If this is a soil, this is a solids, and all voids are filled by water, but this entire soil is inside the some other water. This entire soil is inside the water. Then this is called as a submerged soil. This is called as submerged soil. Then this will also will have a volume, and this will have a some mass also. But this mass is submerged mass. Therefore gamma dash is equal to m dash by v. M dash by v. Right? Now we have got these definitions. The first one is bulk density, saturated density, dry density, and submerged density. Okay. Apart from this, we have two more densities. Let us consider this is your solids and this is your water. Then this is your mass of water and this is your volume of water. And this is your mass of solids and this is your volume of solids. Sorry, volume of solids. Water it is, right? Then we have two more definitions. That is the density of water is mass of water by volume of water. Density of solids is mass of solids by volume of solids. Okay, these are spatial form of densities. Okay, the entire soil is not considered in these densities. This is just water by water, solids by solids, right? This is your densities. Now right now we have studied six type of densities. Bulk density. Bulk density is also called as the wet density. Don't think wet means saturated, no, this is just a wet density or bulk density, dry density, saturated density, and submerged density, then water density and solids density. Okay, if I want to arrange this one in the increasing order, solids density is a bigger one. After that I will be getting saturated density. After that I will be getting bulk density. After that I will be getting dry density. After that I may get water density, or I may get submerged density. Here some fight is there. Sometimes this is smaller, sometimes this is smaller. Right? This is your the order of these densities. Up to here I am very sure about the densities, that this is bigger, smaller, smaller, smaller. But here there will be little different. Right? Now, after this, we will be having another term that is called as a specific gravity. Specific gravity. Specific gravity means it is, you already know the definition, that is mass of standard substance divided by mass of equal volume of, this is just a substance and this is a standard substance. Mass of substance by standard substance, right? Now if I consider this substance as a soil, then standard substance I will consider it as a water. Okay, then here a mass is there, but this mass divided by volume and this mass divided by volume, both numerator and denominator divided by volume. Therefore the top I will be getting density of the top I will be getting density of the soil divided by density of the water. Very interesting. Now look at here, density of the soil, we have a four type of densities. Gamma B is there, gamma D is there, gamma saturated is there, gamma solids is there. Four type of densities are with respect to solids. Then if I write gamma solids divided by gamma W, then this specific gravity is called as a true specific gravity. True specific gravity. Then if I write a gamma B by gamma W, or gamma D by gamma W, then these are called as apparent specific gravity. Apparent specific gravity. Then sometimes this is considered as bulk specific gravity. Only this one is considered as a bulk specific gravity. Bulk specific gravity. Then this one is apparent specific gravity. Then we don't have any formula like gamma sat by gamma w. Okay, this is not there. We have either this is mass, another name is a mass specific gravity, bulk specific gravity, apparent specific gravity. Okay, mass specific gravity. Mass specific gravity, bulk specific gravity, apparent specific gravity, not much in use, but true specific gravity is very, very, very important and we are using it everywhere. This is your specific gravity. Right? Now we have interrelations. We need to study interrelations. Interrelations. The interrelations are, first one I will write gamma B is equal to G plus ES divided by 1 plus E into gamma W. This is the bulk density. And if I want a dry density, then S equal to 0 I have to substitute. S equal to 0 means this will be cancel. Therefore, G gamma W divided by 1 plus E. Very important, very, very important equation. From this equation, if I rearrange the terms, then I will get E is equal to G gamma W by gamma D minus 1. This is also very, very important. Okay, this is also very important. This is derived from here by substituting S equal to 0. Then if I want a gamma sat, then S equal to 1 I have to substitute. In this equation, if I substitute S equal to 1, then this will be G plus E divided by 1 plus E into gamma W. This is your gamma sat equation. Okay. Now, according to according to archimedes according to archimedes principle, then we have gamma dash equal to gamma sat minus gamma w. Here we have gamma sat means g plus e divided by 1 plus e into gamma w minus gamma w. Here take gamma w common and simplify this equation. You will get g minus 1 divided by 1 plus e into gamma w. This is your gamma dash. This is your gamma dash. Right? Now we have further equations. This equation is very important. I call this equation as a switch. That is ES equal to WG. This equation I will call it as a switch equation. Why? Because this will a small equation that will convert into water content to the saturation, saturation to water content, specific gravity to White's ratio. Like that there will be, you can play with this one, acts as a switch. You know? Then we have gamma D equation like gamma B divided by 1 plus W. Another gamma D equation as 1 minus Na G gamma W divided by 1 plus Wg. This is another equation. Okay now? These are all interrelations. You have to by heart these formulas. If you have any doubts till now, you can ask. No doubt? Okay, next one. Next heading is index properties. First, we'll write properties of soil. Properties of soil. See, the properties of soil we can divide into two types. The first one is index properties. Index properties. And the second one is engineering properties. Engineering properties. Index property means by looking at the soil without doing a big experiments, just by doing small experiments, then you will find some meaning of the soil. They are called as index properties. For example, you will do small density test, you will get a density. Density is the index property. Then you will get a volume relations. Volume relations means what? White's ratio, porosity, degree of saturation, air content, and percentage air voids. These are all index properties. Then you have a water content. Water content W, you have water content. You have a specific gravity. This specific gravity is also an index property. Then these are all common index properties. Then after that we will divide soil into two parts. The soil, the first soil is a coarse grained soil, coarse soil. The second soil is a fine soil. Right? Then coarse soil means a soil with the particles bigger size particles. Then here we have particle size distribution, particle size distribution, or you can call it as a C1 lysis, C1 lysis. No? Then this is your coarse grained soil index property. Then we have another one is a relative density, relative density. Okay. Then in fine grained soil we have consistency limits, consistency limits. Okay. Then we have another name for this consistency limits. They are called as Atterberg limits. Atterberg limits. These Atterberg limits are liquid limit, plastic limit, plastic limit, shrinkage limit, shrinkage limit. Okay. Then we have some indices, consistency indices. They are called as consistency indices. Consistency indices like liquidity index, liquidity index, consistency index, consistency index, next toughness index, toughness index, plasticity index, plasticity index, shrinkage index. Okay, shrinkage index. These are all indices. Then after that we have three more properties: sensitivity, sensitivity, activity, activity, and um, thixotropy, thixotropy. Okay, these all are index properties of fine grained soils. Then after that, engineering properties we have. The first one is permeability, permeability. The second one is the second one is shear strength, shear strength. The third one is compressibility, compressibility. Compressibility, in that one we have consolidation, consolidation. Then we have compaction. Okay, these all are engineering properties of soil. Right? Any doubt? Any doubt?
ಸರ್
ಹ್ಮ್
ಸರ್ ಇದೆಲ್ಲ ಪ್ರಾಪರ್ಟೀಸಿಗೂ ಒಂದೊಂದು ಟೆಸ್ಟ್ ಇದೆ ಏನ್ರಿ ಸರ್?
ಎಲ್ಲ ಪ್ರಾಪರ್ಟಿಗೆ ಒಂದೊಂದು ಟೆಸ್ಟ್ ಇದೆ. ಫಸ್ಟ್ ದಿಸ್ ಪ್ರಾಪರ್ಟೀಸ್ ದೆನ್ these three tests are there. Here three tests are there. If you know liquid limit, plastic limit, shrinkage limit, then water content. If you know water content, only these four parameters if you know, then you can just calculate this one. We don't have any test for this one. No tests, no tests, only formulas, only formulas. Okay now, in the laboratory, so see here density we have a two test: sand replacement method, core cutter method. Then volume relations we don't have any test, only formula, only formula. Water content we have many tests, you know, that is oven dry method, then pycnometer method, then calcium carbide method, then torsion balance method, like that. Then ionization method, like that we have many. For specific gravity we have a two experiment. One is a pycnometer method, density bottle method, density bottle method, right? Then particle size distribution we have a two types. One is a sieve analysis, the second one is a hydrometer, hydrometer. Relative density we have only one test, that is relative density. Okay, now this is just a relative density one test. Then consistency limits or Atterberg limits we have, I already explained. Liquid limits we have a two test. One is the Casagrande method, Casagrande method. Then the second one is the cone penetration method. Plastic limit one test, shrinkage limit one test. Then after that these are all formulas. Then sensitivity, this will not come exactly here, this will come in a shear strength chapter. This shear strength chapter is there now. Here we will conduct three experiments. I will explain later. I will come there. Then after that activity, we don't have any test for this one. This is a formula based. We don't have any test or any formula, just it is a concept. Okay now, next here when you come here permeability, we have many tests. Like first one is a laboratory tests. Laboratory tests: constant head method, variable head method, variable head method. Then we have a field tests. Field tests like pumping in test, pumping out test, pumping out test. Then shear strength, we have four tests. First one is a direct shear test, triaxial test, triaxial test, then unconfined compression strength test, vane shear test. Then compressibility, consolidation, one test is there. Then compaction, standard Proctor test, and modified Proctor test. Right? This all comes in a laboratory, but you have to read. That's why in the first day only I told you that how I have to finish all these concepts in 2 months. No, this is very challenging. No? But that's why I'm little bit very fast. I'm explaining very fast. Right? Any doubts? Any other doubts? Okay. Shall we move ahead?
Yes, sir.
Okay. We'll do one thing. Tomorrow, however, holiday is there now. Can we have two classes tomorrow? Others?
Yes, sir.
Okay. Then you can raise your hands, those who want two classes, so that I will come to know. I will arrange a time later. Done. We will have another class because this all things we can discuss. Laboratory only I will discuss. Means how we have to determine these properties that I will discuss tomorrow. And right now we'll move to the questions and answers. Till now whatever we studied, those questions and answers we will discuss, so that we will will get some confidence for this topic. Otherwise you may think that it is very difficult or very huge topic, right? We'll go to questions and answers, so that tomorrow we will make two classes and we'll discuss more about index properties. Okay, we will discuss only those concepts which are covered till now, and if questions appear which is not covered, then I will just skip that. Later we will cover it, right? Now we'll skip the first one. The second one we can try here. I think hope you are able to see the questions, right? We will solve the second question. The soil, the whites ratio is 0.67, water content 0.188, and specific gravity 2.68. Degree of saturation is how much they are asking. Okay, na? Which equation will apply? Okay, whites ratio E is given, water content W given, G is given, S is asked. Therefore, switch equation we can use. That is ES equal to WG. Then S equal to WG by E. Answer. 0.188 into 0.67 divided by 2.68. 47% it is coming, na? No,
Almost 75%, but
75% ಬರ್ತದ? Right, that is the correct answer. Now, which one of the following statement is false? Very interesting, false. Clay deposits are more porous than sand beds. Clay deposits are more porous than sand beds. Presence of organic matter in solid decreases the bearing capacity of the soil. The change of moisture content changes the value of angle of response. None of the above. This we can discuss later because angle of repose is there. Angle of repose means soil you can make it into some heave. This angle is called as angle of repose. You can call it as a phi dash. Then presence of organic matter. See here, change of moisture content changes the value of angle of repose is the correct answer. Presence of organic matter of soil solid decreases the bearing capacity of the soil. Correct answer. Clay deposits are more porous than the sand beds. More porous, they are saying. More porous, no. This is a, we can say, wrong answer. Therefore, the false statement we can consider. Next, the specific gravity of the soil is represented as G and White's ratio E, hydraulic gradient I. Not covered till now. We'll skip. 1.5 will skip. The moisture content of the soil below the volume becomes constant is called as, this we can skip. The sample of saturated clay has a porosity point. This one White's ratio is how much? Okay, you can solve this one. Porosity is this much, means this is n equal to 0.562. White's ratio E I want, therefore E equal to n divided by 1 minus n.
Option A, sir.
Option A is the correct answer. 1.27. 27 or 28, it's okay. Then this we can skip. For a granular soil with increase in White's ratio, the critical hydraulic gradient we can skip. The volume of White's to the total volume of the solid is called as direct equation. The ratio of volume of White's VV divided by total volume. Top floor to the entire building porosity. Right? When a plastic limit skip. Physical property which influence the permeability are skip. Cohesion less soil is, you can answer or otherwise skip. Shearing skip. Ratio of skip. Uniform standard penetration, coefficient of permeability, moisture content of soil, quicksand condition, then bulking of sand, relative density. This one answer. Which equation is correct? Relation between the gamma D percentage air whites, then water content and specific gravity. 1 minus Na, this is plus, therefore cancel. 1 plus Na, cancel. 1 minus Na G gamma W divided by 1 plus Wg. 1 minus Na G gamma W, 1 minus is there here, therefore cancel. C is the correct answer. Okay, na? Plasticity skip. Water content of soil can be, answer this one. 1.26 answer. Other two options are here. No idea? First write down water content equal to mass of water by mass of solids. See here we are comparing water to the solids. Solids is different, completely different, and water is completely different. See here I can have one soil like this where this much of solids and this much of water is there. Means this is equal to this is I can say water content equal to 100%. I can have a solids like water soil like this also. No, solids are very less, water is very more. No, huge amount of water is there. Then here I can say water content is more than 100%. Very interesting. Sometimes I can have a diagram like this, that is solids are very huge and water is very less water is there. Then water content is less than 100%. Therefore, option A, B less than 0% is completely wrong. B greater than 100% is correct. Never be greater than 100% is wrong, because I have many conditions where water content is greater than 100. Takes value from 0 to 100. When I say this is wrong, then this is also wrong. Therefore, most of the students will take this one, but it is wrong answer. The correct answer is can be greater than 100%. Next, this we can skip. Volume of whites. You can answer this one. If the volume of whites is equal to volume of solids in the soil mass, then the value of porosity and whites ratio respectively are volume of whites is equal to volume of solids. Volume of whites equal to volume of solids. Then E equal to 1. Which option? This option and this option. Then N equal to E divided by 1 plus E. Then 1 divided by 1 plus 1, 2. That is a 0.5. Then N equal to 0.5. D option is correct answer. This is wrong answer. You can answer this question. Clay is generally cohesive. Correct answer. Permeable. Wrong answer. Having large particle size. Wrong answer. None of them were wrong answer. That is cohesive. This skip. Now, the volume of whites to the total volume of the soil. Volume of whites to the total volume of the soil. VV by
Forest.
porosity. Correct answer. Then this is a switch equation. First you write somewhere here S equal to WG. Then you compare your answer. E equal to WG. WG by S. Yes, this is correct answer. WSP will not multiply. G and S will not multiply. S and G will not multiply. Therefore, E equal to WG by SP is the correct answer. Finance modulus skip. This you can answer. The relation between E and N. First you write your answer. E equal to N equal to
Option C.
option C. C is a correct answer because N equal to E divided by 1 plus C. Correct answer. Here C, very interesting. If it is a plus, then it would be right. No? But this is a wrong answer. This two will not come. Top two, bottom two parameters will not come. Very interesting. Gravel and sand belongs to the following category of soils. Remember the first this one first origin of soil. Gravel and soil belongs to. Now what we know we will write it, right? Gravel and sand belongs to mechanical weathering. Correct? Mechanical weathering or physical weathering. Okay na? Then physical weathering means the soil physical weathering ಅದರೊಳಗೆ ಏನೇನು ಬರ್ತದ? Wind ಬರ್ತದ. Wind is there, water is there, human action is there, frost action is there, root action is there. See, these all actions are what they are doing. They are transporting the soil from one place to another place. Wind transporting, water transporting, human transporting, root action transporting. They are all transporting the soil. Therefore, gravel and sand, I can say that is a transported soil. Which of these is a transported soil? Cohesive soil, no. Clay, therefore this is not answer. Marine soil, just below the sea, not answer. Expansive soil and cohesive soil both are same, therefore not answer. Therefore alluvial soil is the correct answer. Correct? Huh? This skip. Which of the following statement is correct? Can we see this one? In a dry soil, all voids are filled with air. Correct. In dry soil, all voids are filled with air. Correct. In saturated soil, all voids are filled with water. Correct. In partial saturated soil, voids are
Option D.
very good. When we tick two options correct, then option D is the correct answer. Next, see this much easy questions they will ask. Na? The voids ratio for saturated soil is equal to dash of water content and specific gravity. Hmm. Voids ratio of saturated soil. Saturated soil means S equal to 1. We will write equation ES equal to WG. Now substitute E equal to W into G. Right. Now come here. Is equal to dash of water content and specific gravity. What? Sum product difference ratio. E equal to WG. Down, down. Product.
Product.
Yes. Specific gravity of a soil is same for clays and solids. No. Determined by hydrometer. Maybe will hold. This is wrong. Less than 2 for most of the soils. Wrong. More than 2.5 most of the soils. Tough competition. Specific gravity of the soil is hydrometer. Very interesting. Hydrometer is the instrument used to determine specific gravity of the liquids. Not right. Tough competition is there. Specific gravity is the instrument used to determine the liquid that specific gravity of liquids. Hydrometer. Right? Therefore, this is wrong. Now it is wrong. Now this is wrong. This is wrong. Therefore, D is the correct answer. Density index, skip. Pores of a soils are completely full of air only, then the soil is said to be dry. Soil sample is having a voids ratio 0.5 and porosity shall be close to answer it. Hmm.
Option D.
Option D, right answer. Go to the next question 1.46. Hmm. The voids ratio E. Soil sample having a porosity N, moisture content 25% uniformity. Student fan ಬಂದ್ ಮಾಡ. Okay, coefficient of info. Which of the following represents the measure of particle size range? Right, correct answer. Next, the White's ratio of the soil sample 0.58 and the porosity is this much. Hmm. Others, B answer. Can solve that later. Next, will come to coefficient of curvature, well graded, coefficient of uniformity. Huh. Casagrande apparatus is used to determine what? Liquid limit. What would be the White's ratio of the soil if the porosity of the soil is 0.35?
Option C.
Option C. Done. Liquid limit will skip, falling head will skip, organic curve, grading curve gap will skip. Which of the soil possesses zero plasticity? C number. Sand obtained from pits is washed to remove clay silt. From which of the plasticity index? Falling head thickness. Which of the following range during the flow grading according to Indian standard? The ratio of this one 97. Defines the porosity. The ratio of volume of whites to the volume of
Option C.
option
Option C.
C. This is already wrong.
C.
Then
Volume of whites to
total volume. Correct answer. Water content at
Sure,
which
option is
option A? No. Volume of solids they said no. Therefore no.
option C.
Volume of water. Option C is the correct answer. Next, water content at which soil changes from liquid state to this one. No toughness will not required right now. The saturated soil. This one. Saturated soil sample has a dry unit weight this much. Specific gravity this much. Unit weight of water is this much. Determine the water content of the soil.
Shrinkage limit.
Mm-hmm. This 100th question. Gamma D is given. G is given. Gamma W is given. No, no. Look at here. ES equal to WG. S is equal to 1. because saturated soil. Then G is given 2.65. Water content they are asked. E we can calculate. Right? E equal to G gamma W divided by gamma D minus 1. What is G? 2.65. Mm-hmm. Don't have calci?
Option A, sir.
Option A. Okay. Next. The most accurate method used in a laboratory. You can answer this question if you know a little bit of geotechnical.
Oven drying method.
Very good. We have oven dry method is the
Option
most
A.
most accurate method. Okay. Next, submerged weight of a soil solids per unit volume is submerged unit weight. Weight of unit, wet unit weight alla saturated unit weight, dry unit weight, buoyant unit weight, and submerged unit weight both are same. Submerged density or submerged unit weight both are same. Buoyant is also same. Next, diameter of the CU unit classified toughness. Now 107. Glacier deposited soil is called
Till.
hmm,
Till.
till. ಅಲ್ಲ drift talus loess is wrong. Glacier deposit of soil is a drift, I think. Till is an example for colluvial soil. Correct? Am I right? 1 minute.
No, sir. Till only, sir.
Till is a glacier deposit. Talus is a colluvial. Drift is, but drift is also there. Yeah. Talus is a wrong answer. We have two options here. Till is also there and drift is also there. Drift in our slide that drift was didn't come, but we'll put a question mark here and we'll take this D. No, we'll check it. Hmm? Anyone want to comment? Next, field specific gravity, White's ratio, water content, fully saturated. Okay, you can answer this one. Soil has a specific gravity G equal to 2.5. White's ratio E equal to 0.75. Water content of fully saturated S equal to 1. Then W equal to ES by G. E by G. S gone. E 0.75 by G 2.5. How much? 2.5, 25% or 30%? Not 30, 25 might be right answer. Then this is already discussed.
Sir, 13 month.
30 ಬರ್ತೈತಿ. Okay.
Yes, sir, exact
Okay.
30 months.
Okay, right. Then this is not easy. Then this will skip. This will skip. This one, see. Volume and weight of air, water, and solids in a soil mass is given in the table. Very interesting. See options. What are those? Which of the statement is correct? Okay, we'll answer those. Soil is partially saturated with degree of saturation S equal to 60. S equal to 60 ಬರ್ತದ. Water by whites, that is 0.3 by 0.5. Am I right? 0.6 correct answer. Yes is right. Whites ratio is 40%. 0.5 by 0.5 1 ಆಗ್ತದೆ. Therefore this yes is wrong. Water content 30%. This side I have to come. 0.3 by 1 0.3 correct answer. Saturated unit weight 1.5. Saturated unit weight ಯಾರು ಹೇಳ್ತೀರಿ ಇದನ್ನ? Interesting. Very interesting. Those who tell this answer means they know much more in first chapter. Whether that 1.5 is right or wrong, that's it. Did not get? क्यों हिला डाला ना? Here this is very interesting. Why? Because look at here. This is your three-phase diagram. This is given water volume is 0.3. Volume is 0.2. This is 0.5. Total volume is 1. Correct? Total volume is. Mass is how much? 0.3. And this is one mass and this is another mass. Is there any mass here? Water mass? Air mass? No. But they are asking saturated. They are asking saturated means this must be filled by water. when this must be filled by water, then how many grams will be having? This is 0.3 gram, 1 gram, and how many gram of water will be occupied here? How many gram? Look at here. 0.2 centimeter means will occupy 0.2 gram. Why? ಈಗ ಹೇಳ್ರಿ ನೋಡೋಣ. Why it is like this? 0.2 centimeter cube. Here 0.2 centimeter cube means 0.2 gram. Why? इशारों से समझने वाला, कहने पर समझने वाला, कहने पर भी ना समझने वाला. तीन type of people are there. Now I have given you hint. इरशाद इरशाद बोले. No, you should remember, no, water density is 1 gram per centimeter cube. Water density is 1 gram per centimeter cube means zero point 0.2 equal to 0.2, no? Therefore, at this point I will write 0.2. Then the total will be 1 plus 0.3 plus 0.2 becomes 1.5 divided by 1. Therefore, 1.5 gram per centimeter cube is a right answer. Therefore, S1, S3, S4. S1, S3, S4 is the right answer. White's ratio is defined as the ratio of D option. We'll skip. Ratio of volume of water present in a given soil mass to the total volume of whites is called. Hmm? Degree of saturation. This will skip. This will skip. What is the capacity of density bottle? Will skip. Who is known as father of soil mechanics? My name is nahi hai isme. Who is the father of soil mechanics?
Sir, D.
D. Correct answer. Next. Odometer, plasticity. Which of the following statements are true? This one. Bulk unit weight 20, gamma B 20. Water content W 0.17. Then soil particles dries to a unit weight of gamma D 19. White's ratio remains constant. What they are asking? Look at here. Soil has a bulk unit weight of 20 and water content 17. Calculate the water content if the soil particle dries to 19 kilonewton per meter cube and White's ratio remains same. Any idea? Two conditions are there here. Bulk unit weight, when it is like this, then your water content is 17%. When it is 20, your 17% water content was there. Later, the soil dries to a unit weight of 19 and White's ratio remains constant. Then what is your water content? dry density, sorry, bulk density is how much? 20 kilonewton. At that time, water content 17%. Now, dry density is 19. Then what is your water content? Correct? Rise to a unit weight of 19. Sorry, not gamma D. Means when it becomes 19, how much is the water content? That's it. See here, gamma B is equal to gamma D divided by, sorry, gamma D is equal to gamma B divided by 1 plus W. Then gamma D1, gamma B1, W1. Gamma D2 is equal to gamma B2 divided by 1 plus W2. Very interestingly, when they say White's ratio remains constant E1 equal to E2, then only you can write gamma D1 equal to gamma D2. Mind it. E1 equal to E2, then only you can write gamma D1 equal to gamma D2. Then I can equate these two equations. Gamma B1 divided by 1 plus W is equal to gamma B2 divided by 1 plus W to 1. Now, this is a 20 divided by 1 plus 0.7 is equal to 19 divided by 1 plus W2. Answer.
So 11.
11. Okay, is there an option? Right. According to Terjgi, Peck, soil sample, calculate White's ratio. White's ratio equal to n divided by 1 minus n. 0.25 divided by 1 minus 0.25. 0.75, 25 ones are 0.35, 0.33 is the correct answer. 34. Then height of the sample is to be tested 20 centimeter. Height of the saturated sand is to find the bulk density. No, not at. Sand bath method, water content. Identify the method that is not used for determination of in situ weight of natural soil deposit. In situ weight, sand bath method, core cutter method, water displacement, sand replacement. Not sand replacement is a method to in situ, core cutter is a method to in situ, water displacement method and sand bath method. Sand bath method is for water content. Sand bath method is for water content. They want natural unit weight. Therefore, this is the correct answer. This is the wrong answer. Not, therefore, this is the right answer. Unconfined. 137. Lacustrine soils are those which are transported by rivers, streams, by seabed, wind, lake. Lacustrine lake. No, that you remember. Activity. Soil transported and deposited. Soil transported and deposited by river or stream is called as alluvial soil. Saturated unit of the soil is the ratio of total void to saturated bulk unit weight. Wrong. Total volume to the saturated bulk unit weight. Wrong. Bulk unit weight of the soil when it is fully saturated. Right. Saturated bulk unit weight to the total void. Wrong. This one. Mass of a chunk of a moist soil is 20 kg. and the dry density is this much. What is the White's ratio of the soil when specific gravity is this much? Take 1000. Hmm. How to do? 20 kg, 1500 White's ratio they are asking, specific gravity 2.5, gamma D, this one, E we can get. Bantala. E equal to G gamma W divided by gamma D minus 1. That is your 2.5 into 1000 divided by 1500 minus 1. 2.5 divided by 1.5 minus 1. 15. 5 ಮೂರ್ಲೆ 15, 5 ಐದ್ಲೆ 5 by 3. 3 ಒಂದ್ಲೆ 3 ಒಂದ್ಲೆ 2 ಉಳಿತು 20. 3 ಆರ್ಲೆ 18. 6. 1.6 minus 1.6. Answer is B. Remember, your first paper 1 calculator is not allowed. In paper 1 calculator is not allowed. No? You solve this problem. You solve this problem. You solve this problem. Next, you solve this problem. Over. Tomorrow we'll start the other syllabus. Okay, any doubt? Anything you want to discuss? Okay, tomorrow I will tell that 8:30 to 10:30 evening class will be there. That is as usual. But extra class timing I will tell you 1 hour before the class in the group. Right? If you want to ask, we can ask.